Welcome to Study Loop.
Part A of the given problem, the centripetal force exerted on infinitesimal of the blade with mass dm at a distance located at r from the rotational axis. We can write the force by using a Newton's second law, that is a dF will be equal to dm mass times omega square r, where dm can be written as m divided by total mass divided by L times the dr, and the angular speed is omega, which is 320 revolutions per minute, converting into radians per second. That means multiplying with 2 pi divided by 60. This gives us 33.5 radians per second. Thus, for the entire blade of the mass m, capital M, and its length L, the total force can be written as integral of a dF, which is equal to omega square r dm. From here, we substitute the dm, and in terms of dr and ml, we take out lml, integrate over 0 to L, omega square r dr. So this simplifies into force will become m omega square times L divided by 2. We substitute the values and find the force. So force will be 110 kg times 33.5 is our omega times 7.80 divided by 2. This gives us force of 4.81 times 10 to the power 5 Newton. So this is our force. Part B. About its center of mass, the blade has a rotational inertia of I is equal to m L squared divided by 12. Looking in a table and using a parallel axis theorem to move the axis of rotation to its end point, we find rotational inertia becomes I is equal to m L squared divided by 3. Then using the definition of torque, T is equal to rotational inertia times alpha. We substitute the value ml squared divided by 3, and alpha is delta omega divided by delta t. And from here, substituting values 1 over 3, 110 times 7.8 meters squared times 335 divided by 6.7 seconds. This gives us a torque of 1.12 times 10 to the power 4 Newton meter. Part C, the work done is equal to the change in kinetic energy. That is equal to 1 over 2I omega square minus sign. So let me just use minus 0. This gives us, putting the moment of inertia here, 1 over 2, 1 over 3 ml square times omega square. Substituting values 1 over 6 times 110 times 7.80 square times 3.5 square. This gives us the work done to be 1.25 times 10 to the power 6 joules.